Hi, so today making carbon dioxide and testing it. A number of things you need to know. You need to know apparatus setup. This is the same apparatus I used, exactly the same apparatus I used to make oxygen. The chemicals are different. Different reaction gives you different gas, but the chemical apparatus is just the same. We're making carbon dioxide gas. See, look, CO2, carbon dioxide gas. It's going to be made here. We're going to collect bubbles of it. But the two chemicals you need, we're going to use this reaction where an acid reacts with a carbonate, always makes salt water carbon dioxide. It is a reaction we will do in year 10. So, year 9, I'm simply going to ask you to think of that reaction I've written at the bottom there. Calcium carbonate reacts with hydrochloric acid, makes calcium chloride, which is a salt, which will stay in that flat bottom flask. It will stay there. Water will stay there. The carbon dioxide gas will bubble up, come out the short tube. Let's move this up. So the bubbles of carbon dioxide will come out the short tube here, come down the delivery tube, bubble in my trough of water, and I'll collect them in a test tube that's full of water, and the carbon dioxide gas will push out the water that's in the test tube, and that's how we're going to do it. So let's get on with it. Let's put you at a position where you can see the apparatus there. So, hydrochloric acid, going to use hydrochloric acid, and marble chips. These are, believe it or not, marble chips are just teeny weeny pieces of marble. So, just mantle the apparatus, get some marble chips, just put them in, perhaps some more. Put them in. Probably enough. Put the top on. So long tube needs to go underwater. The short tube allows the gas to come down here. I've got some test tubes here full of water in the water to save time. I now put hydrochloric acid into the thistle funnel. The bubbles there will be bubbles of air. So we want to let the air escape. You just make sure that's on tight, airtight. And then I should have bubbles coming out here. Now, I can collect using a test tube here, upside down test tube. There, and I've got nothing coming out. So I've probably got a leak. It's probably this bung isn't on tight enough. There, you press the bung down, and then I am getting bubbles. So that is one test tube. Let's collect another test tube. Another test tube, third test tube. I'll do something with this one. So I use that memory aid, Cod Slipton, and if I go through that, C for colour, carbon dioxide is colourless. O for odour, well, I'm going to smell this test tube here that I've just collected. O, odour, does not smell. So it's odourless. It's colourless, it's odourless. Now density. It is much more dense than air. Carbon dioxide, 24 litres of it weighs 44 grams. 24 litres of air weighs about 28 grams. 44 is considerably more than 28. So it's considerably more dense than air. Carbon dioxide is considered to be a dense gas. So if we had it, it would, by gravity, it would sink if it was in air. I can talk about that later. The density is more than air's. Solubility. Well, it dissolves. It dissolves in water really quite well. You know the fizz in your fizzy drinks? That's carbon dioxide. And that carbon dioxide was inside your fizzy drink. When you take the top off, you may see bubbles of it escaping. But it goes into the drinks really quite easily. It's quite a soluble gas. Now you might ask, if it's so soluble, what am I doing collecting it underwater? Well, I make a lot of it. Some of it dissolves, some of it doesn't. The bit that doesn't dissolve, I collect. So I can still collect it over water. I will lose some collection. I will lose some gas into the water, but I don't care about that. And that's why I can still do it in this method. It's called collection over water. However, you can have a different apparatus setup. You could have a test tube which collected it downwards. It's called downward displacement of air. You collect hydrogen with a test tube up like that. You collect carbon dioxide with the test tube down like that. I like the water displacement because I can see it. I know how much I've collected, etc. So, COD, cod, solubility. L for litmus. That's like, is it an acid, alkali, gas? And for that, I can use universal indicator, which is green. Add a bit, shake it up. It's gone yellow quite rapidly because carbon dioxide is an acidic gas. It's not a strong acid. It makes a weak acid in water. So when we shake it up, I've got a weak acid in there, and it's called carbonic acid. But that carbon dioxide gas is considered to be acidic, and that's an important property. The fizzy drink that gives you a sharp flavour, that sharpness in your mouth, is the acidity. Acidity has a sharp flavour, and the bubbles together with the sharpness is the reason why my grandchildren like Diet Coke, for example. So fizzy drinks rely upon the acidity and the solubility of carbon dioxide. How about burning it? Right, let's burn it. Now, I've got a splint here. I've got a tube here. I'm going to take the bung out and put this in there, and it goes out. Things don't burn in carbon dioxide. Indeed, carbon dioxide is used as a gas to put out fires. It's used in fire extinguishers to put out fires. P, is it poisonous? No, it's not poisonous, but you need oxygen to live. So if you just breathe this gas, you will die. It's not the gas that kills you, it'll be the lack of oxygen that kills you. T is the test. Well, we should have done this before. In previous videos, you should use lime water with carbon dioxide. Should give me a white precipitate. So here goes. Take the bung off, put some of that in, put the bung back quick, put the bung back, and I'll shake it up. White precipitate. The white precipitate is proof that the gas was carbon dioxide gas. Uses, two main uses I want you to quote. One is that it's used in fizzy drinks. The other one is it's used in fire extinguishers. Notes. Well, the notes with this would be that carbon dioxide is used by plants in photosynthesis. Right, let me take you through some of those ideas again. So, that down there is the general equation we will teach you in the future. I don't think I've taught it in my videos yet, but I will do when I tackle acids. So acids react with carbonates, make salt water, carbon dioxide gas. What I want to do with you today, though, is those Cod-Slipton properties. So, C for colour, colourless, odorless, density is more than air density. Solubility, good in water. So dissolves in water basically. L is litmus, it's an acidic gas. I for inflammability, does not burn. And things don't burn in it. Does not burn. Things do not burn within it. P for poisonous, not poisonous. T for test, shake with lime water. You get a white precipitate. Proves it's carbon dioxide gas. Uses, fizzy drinks. The fizz is carbon dioxide. And fire extinguishers. N for notes, plants use carbon dioxide gas for photosynthesis. So, Cod-Slipton properties, you need to know those. Reaction, standard acid reaction used to make carbon dioxide gas. The apparatus is just the same as the apparatus we used for oxygen. And there we have the preparation and properties of carbon dioxide gas. Okay, see you next time.